Okay, this one is the Newton universal law of gravitation. Okay, now we see what they're talking about. Okay, first one, moon around the earth. I think everybody know lah. So another one is an apple fell vertically to the ground. So this is one of the questions. Why? Why they do not fly up? They need to fall down. Okay, so we're going to see the reason to make it become like this. Okay, you can fill in the blank for the question for your first page and the second page, your sum of the activity. They also got question. So you can refer here, okay, to give the answer for the question. Okay, the first one, a person who jump up, they will return back to the ground. What forces to pull the person go back to the ground? So we only got one of the force because they're from the center of the earth. We call it as a gravitational force. Okay, they pull the object go back to the center. Okay, number two, the A molecule that remain at the atmosphere without escaping to the outer space. So what forces also acting between the molecule and in the atmosphere and also the earth? So that means they got a molecule, very small, but your earth is very big. Okay, but both also pull by each other. So finally, you find this one, the A molecule, they never moving to the outer space because they still got the force to pull the A molecule to come back, okay, to come back to the original place. So this one force, we still call it gravitational force. Okay, excuse me. Although the Earth is a big size, the A molecule is very small, but both also pull by each other using the force is the same. So from here you find it, the A molecule, they only come back. They never go up. But the Earth is not moving. So the question you ask, if both also pull by each other, why the A molecule, they come back, but the Earth, why they never move? So this one's later, we need to answer this question. Two also pull by each other. The force also same. Why one you will be stay, another one will be move? Okay, so now we go through the question. Move around the earth without drifting anyway. Okay, from the orbit, you see the moon, they will round the earth. Okay, they never run from the orbit. They keep moving. Okay, keep moving around the earth. So the earth exert pulling force on the moon. Does the moon also exert the force from the earth? Okay, so the answer is yes. Both sides must have the force. If not, the moon will run from the orbit already. They will run from the track already. So both sides also got the force pulled by each other. So finally, they do not run out from the track. They will keep in the same positions. So now we continue the activity. Okay, the leaf, they fall from a tree. Okay, they fall down. Are both leaf and also the earth experience the same gravitational force? So they ask you, I know about gravitational force, but is it same or not? Okay, the answer is same. It's same. Okay, now they continue the question. What is the effect of these forces to movement of the fallen leaf and also the earth? What's the effect? So the effect, you only see the leaf. You cannot see from the earth. So we find it, the effect is the leaf and the earth also move towards to each other. Okay, the force pull by each other. Okay, this one is your leaf. Okay, this one is your earth. So you see the leaf pull. This one also got pull. Both sides also got pull. But finally, why does the fallen leaf move towards to the ground? Okay, why the earth is nothing happen? We only see the leaf keep falling only. So now we give the reason. The mass for the earth is very, very large. Okay, large, very large lah, compared to the leaf. So the gravitational force that does not have any apparent effect to the earth. They don't have any force can be attacked to the earth. So finally, the earth still stay at there. So finally, we only can observe the leaf falling. So that means you pull by each other, you see something, the apple fall down. So we never see the earth is moving because the earth, the mass is already big enough. So big enough, that means you cannot see they got any gravitational force to pull on the earth. We only can see the lighter object that produce a gravitational force, then they pull to the center of the earth. So this one is one of the reason you cannot see the earth got moving. You only see the object fall down. But when the question asks you, the earth got gravitational force or not, you cannot say no. You must say yes. Both sides also got. Then they ask you the value same or not, the answer is the same. Both also produce the same value of the gravitational force. Okay, after that, one can move, one cannot move. That one is depend for the mass. Okay, so we go and see. If we're talking so much this one, we need to see what is the formula related for the gravitational force. Just now we're talking about mass. Okay, and distance also one of the things to be affected. Okay, later we see the distance. Okay, gravitational force. Okay, we're talking about the sun and the earth. So gravitational force between the sun and also the earth, both also pull by each other. Okay, this one, moon and also sun also got gravitational force. And the last one, the moon and the earth also got gravitational force. So this one, we call it as a gravitational force between the sun, between the earth, and also the moon. So you can find gravitational force only acting for two bodies. They don't have three bodies joined together. Sun with the earth, sun with the moon. We cannot sun with the moon and the earth together. So we only count for one body to another body. So you can see the arrow is pull, go outside. This one also pull another side. So the opposite direction. Finally, they will never move to each other. They will continue the track and also moving. So if the object, the mass is very, very small, so that means you can find the object, there's a fall down. If for the earth, there's a fall down. Okay, now this one, gravitational force, we also can call it as the universal force. Okay, when they're talking about sun, earth, and also moon, we're talking there's a universal force. Okay, we're just talking about the leaf, the body and body pull by each other. That one we just mentioned gravitational force lah. Okay, because they act between only two bodies in the universe. Gravitational force exists only between two bodies. Okay, both body also experience gravitational force, same magnitude. So means the value is the same. You pull me how many? I must pull you back. The value is the same. Okay, so this one we call gravitational force. Okay, we see the Newton universal law of gravitation. Okay, relationship involved to the gravitational force. Okay, we related with the two bodies. You see body one pull body two. So that means body two also pull the body one. Okay, now we need to create the formula. Newton law, first one, they're talking about gravitational force between the two bodies directly proportional to the product of the masses. So that means you more than one mass. Okay, you got two body, that means you got two masses. Okay, now they say directly proportional, means they're talking about this formula. F, gravitational force, directly proportional to the two body masses. Okay, M1 and 2. That means body 1 and body 2, the masses. Okay, number 2, they're also talking gravitational force inversely proportional to the square of the distance between the center of the two body. This one is the center of the two body. Now when they pull, this one is a distance, R. Okay, so they say F is inversely proportional with R square. So they say square of the distance between the center of two bodies. So they create second sentence, the meanings. Okay, now I want to combine. When I just combine number 1 and number 2, then I create number 3. Force directly proportional M1, M2, then over R square. So you must know M1, M2 is what? M1 is the first body mass, M2 is the second body mass, and the R square is the center to center, the distance. Then after that, you go to square. So this one is one of the thing related with the gravitational force. The mass will related with gravitational force. The distance also related with the gravitational force. So they got two factors. How to make gravitational force increase, how to make it decrease. Okay, now we continue again for this formula. Okay, I want to ignore this one. This one is a directly proportional. Remember, every time you go to write an example, F directly proportional with the A. Okay, so from here you just write, you plot the formula. Okay, F over A. So you get directly proportional. Okay, this one directly proportional, you find the gradient is what? Actually, it's a F equal MA. So M is a gradient for this part. Okay, so from here, we normally want to take out this one L directly proportional. You must put one constant value. Okay, constant value. So from here, they create the constant value is a G. This one we call gravitational constant. Wait, I will find the name. Okay, this one G, we call it as a gravitational constant. Yeah, gravitational constant. There's a one constant value. You press your calculator, you can get it. Later, I'll show you how to press it. Okay, this one gravitational constant value. So you from here, what means of the F? Gravitational force. M1, first body mass. M2, second body mass. Okay, R is a distance between center to center. Okay, gravitational constant. This one is always constant, 6.67 times 10 power negative 11. Then this one is a unit lah. Newton meter square per kilo square, per kilometer square, kilogram square. Okay, so remember this one is a gravitational force. Okay, we're using the universal law of gravitational force. So F equal G, constant value, M1, M2 over R square. So this one is the first formula to show you gravitational force. Okay, now we're going to see how to place the G. Okay, the question will provide this one. Okay, if you want fast, how to press? Okay, now I show you. You take out your calculator. You calculate the bottom. Get the cover. The cover, they got label. This one. They got label. You can see 39. 39 got mentioned G, is it? Okay. So this one is a gravitational constant. How you go to press? You press the calculator, the corner side. C-O-N-S-T. C-O-N-S-T, this part. This one. Okay. You press it. Okay, then you press 39. Then you produce a G. They come out one G. Then you equal. Then they show you 6.67384 times 10 power negative 11. So that one is a G. Okay, if short form, they give you 6.67. So this one is every time you don't need to press the calculator for long. You just press C-O-N-S-T. After that, 39 equal, then get the G already. That one is a gravitational constant. Okay? Until here, still okay or not?
Yes, teacher.
Okay, so we're going to try example 1 question. Okay, every time I just remind you to write the info before we start to answer the question. So from here, they say two objects with the mass. So they want to find the gravitational force, at least got two objects lah, because you want to pull by each other. So from here, the first one, they tell you 35. Okay, place at the 4 meter. So this one sure is a distance from each other. Then after that, calculate the gravitational force between the object. So two object also mass is the same. Okay, that means this one and this one, you are 3.5, I also 3.5. And the distance center to center, there's a 4 meter. Okay, so they ask you, what is the gravitational force? Okay, so from here we write the info. Okay, then after that G. G, I told you already, you want to fast, you just press your calculator by using just now the constant, CONST, then 39, then equal, then get already. If not, you want to press this one, also can. Okay, after that, we go to apply the formula. F equal G M1 M2. Okay, I think this one is your question paper, the example question 1. You can write from there. Okay, I just apply, I show everything here. I show the calculation, 3.5, 3.5. Remember, many students, they forget for this one square. They forget for this one square. They just put 4. So remember, must square. When you just lost this mark, then the following you were wrong already. Okay, so we put square, so it becomes 16. So finally, I just show the answer. The answer is too long. You no need to write too long also can. You can write 2 decimal point. After that, answer by standard form. Okay, I get it like this only. Okay, 5.11, maybe behind got so many lah. So I just put 2 decimal point. After that, I put standard form times 10 power of negative 11. Don't forget the unit, because you find the gravitational force. It's still the force, so we're still using Newton. Okay, so this one is the first apply formula for the info only. So they never run anyway. The question always is a straightforward. Important you understand the question. Okay, this formula provided for the exam. Okay, so we go to the next question, example 2. Okay, example 2. Okay, we see the info. The mass of the Earth and the mass of the Moon. Okay, now they're using Earth and Moon already. So this one is Earth. Okay, after that, this one is a Moon. Yeah. Okay, if the gravitational force between the Earth and the Moon, okay, they provide gravitational force. What is the distance between the Earth and the Moon? Okay, so this one question, they want you to find is a distance. So we still write the info first. Okay, Earth, then this one is a Moon. Okay, after that, we know the gravitational force. G also provided, but I don't know the distance. Okay, so we still apply the same formula. Okay, apply the same formula, and you put all the info in. Okay, I want to find the R2. So I take out the R square here. Okay, after that G, then I put the F. Okay, I put the F at the bottom. So I need to put in all the info. R square. Okay, this one is a G. This one is the Earth, M for the Earth. This one is a M for the Moon. Okay, then this one is a F, gravitational force. So I find should be the R square. Okay, so finally I don't want got R square, I just want the R. Okay, I don't want the R square. So you need to square root the answer. Okay, the number is quite big. So the student, when you press the calculator, please using bracket. Okay, using the bracket, don't straightforward power, after that multiply power, again finally equal. The answer is wrong one. Better you put the bracket. If you're more careful, then you write out. Okay, after that, you multiply 1 by 1, then you write out. That one is more safe lah. Okay, so just suggest you don't type 6.67 times 10 power negative 11 because so many things you want to type. You straightforward press, there's a G first. Okay, after that, you bracket, then you type 6 power 24. Okay, then you bracket again, 7.4 power 22. Okay. Okay, one more thing. You know the power, how to press? You just press the pi. Have you seen the pi? The pi is a multiply 10 power x, is it? So you press 6, then you power straight. You got power 10 already. Okay, you can try. 6, after that you take the pi, the one got 1 pi. Then you press, there's a power already. Then you put 24. There already is a 6 power 24. Okay, then you divide. After multiply, then you divide by 2.05. Also put bracket, power 20. Okay, so I get the R is how many? I get the R square is 1.45 times 10 power 17. Okay, but this one still not yet the answer, because I want the answer is R, not R square. So finally, you straight the answer. You press the calculate the answer already. You straightforward square root, then answer. So that means you no need so many times you type again. Okay, you get the answer from the R square. You straightforward square root. The answer equal. So from here, I get the answer. There's a 3.81 power of 8. The power must be correct. Okay, decimal point, you put 2, then enough already. Okay, any problem? For your calculator, do you know how to press? Be careful, this one question, this topic lah, normally the answer like this one. Because the number is quite big. So they're using the power. Okay, you must be careful and also must be more practice to press your calculator. Okay, you see the effect of the mass and the distance between the two objects on the gravitational force. How the mass and distance, okay, to the gravitational force. Okay, this one is an activity 2 from your the notes from there. Okay, imagine you and your partner are the body at the rest on the earth. Okay, record the mass and also your partner mass. Okay, so from here, we're going to see the first one example. I say 50 and 53. Okay, both also high mass. Okay, both the mass is almost the same lah. Okay, but the distance is a different. Okay, you and your partner. Okay, distance 2 meter. So we need to count the gravitational force. So we use the formula is the same lah. The formula is F equal G, then M1, M2, then over the R square. So I'm using this reading 50, 53. Then after that, over 2 square, there's a 4. So I find it. This one is a gravitational force. You see, very small only. Negative something. Just now we do the calculation already is a sun and also the moon, the earth and the moon already power is more. But now you see your body and another body like this only. Okay, because our mass is very small. Okay, and the distance closer. So from here you see this has a 4.4 times 10 power negative 8. Okay, if I go further, the distance become 4. So you find it, okay, the gravitational big a bit, 1.1. Small a bit, not big a bit, small a bit. So that means from here I can conclude, distance further, gravitational force become less. Okay, distance further, then the gravitational force become less a bit. Okay, next, if I using the mass is small, 144, 45, another one is 55. Okay, compare just now. Big, this one is around 10 kilogram different. So the distance same. So I go to adjust when 2 meter, what happened? I get 4.1. Okay, if 4 meter, 1 only. So from here, I can make a conclusion is, if the mass difference is less, this one is less, is it? This one big difference, is it? So you see the mass, both also high, the reading is quite higher. If the mass 45 and 55, because this one low this one low mass, so you can find they drop a bit. Gravitational force will drop a bit. Okay, the distance sure already. When you just further, the gravitational force will be less one. So from here, the conclusion I get it is, when the mass just increase, your gravitational force will be increased. When the R you just further, then the gravitational force will become less. Okay, so this one is a conclusion. We get it when you just try to do the calculations. Okay, so from here, how does the masses of the two bodies influence the gravitational force? So we find it, the bigger the mass, the greater the gravitational force. Okay, so this one I get it from the calculation if I'm using the different mass of the body. Okay, number two, what is the effect, the distance between two body of the gravitational force between them? So I find it, if the distance further, gravitational force become weak, become less. So from here I go answer, as the distance increase, the gravitational force will be decreased. So distance and the force inversely proportional. So I can show the formula already. R squared. So you can see the force and the R inversely proportional. Okay, after that, the force and also the mass directly proportional. Force and mass directly, force and R inversely. Okay, so this one is a two factor will be affected the gravitational force. G, no, G is always constant. Okay, so I go to change the slide. Okay, so this one is the conclusion we make it. The larger the mass, so you see this one's the larger lah. Okay, the larger the mass, the larger the gravitational force. So I can say the force F2 is more than the F1. Okay, to pull to each other. Okay, second diagram is the gravitational force decreases when the distance between the two body increase. So you can see this one is more further. This one is R is larger. Okay, the force from here only. Okay, so this one R is, this one is more big. Okay, this one is small. Okay, so F1 is strong. F1 is stronger than the F2. So from here, gravitational force is higher for the F1 when you just closer. Okay, so we see the factor. The factor only two, mass. Another one is the distance. So mass increase, gravitational force increase. Distance increase, gravitational decreases. Okay, now we're going to see the problem solving related with the law of gravitation. First one, two objects rest. If two objects rest on the earth, example, you and me, okay, face to each other. So this one is an object rest on the earth. So we create two forces. One is force, first body pull second body. So we say 1, 2 lah. One body pull the second body. Okay, for the second body, you also pull. You from your body, pull the first body to come. Okay, so from here, we see 1 pull 2. This one, 2 pull 1. Okay, suppose like this lah. So from here, we just see both to pull each other. This one is a R. Okay, so this one is a R. So from here, we just write first force and the second force is the same. Okay, although opposite direction. So we put the modulus, no more opposite direction, all positive. So from here, both force is the same. So this one force, we call it as a gravitational force. So they create the formula, this one. Okay, the force, the gravitational force we learned before. Okay, second one is this one. Object on the Earth's surface. Earth's surface. This one called Earth's surface. Okay, at the surface. So Earth's surface to pull. Okay, object on the Earth's surface. So we see object on the Earth's surface. This one is the center. So we pull. Okay, both sides to pull. So we're going to see object on the Earth's surface. We're still using this formula. Okay, but I know this one R is how many? This one R is a radius. Because you are on the surface of the Earth, this has a center. So when you pull this one, we call it as a capital R, radius of the Earth. This one R, no, this one R is a body and body distance. Maybe 4 cm, 10 cm, or something like this. But this one is exactly the radius of the Earth. Okay, depend the question. The question will tell you, oh, now the satellite is on the surface of the Earth. Then you know the distance is a radius. Okay. Then the third one. Okay, the third one is the satellite far away. Okay, example, the diagram like this. So the Earth and the satellite. If the satellite already launched, that means they're further from the Earth. So that means we need to add one more distance. If the satellite just before launch, they're on the surface, that means we're using radius. Now we see another one. Okay, now the satellite already launched. Okay, launch further from the Earth. Far away already. Far away means we got two distance. We got radius, we got h. So you need to plus together. When you apply this formula, the r square. So the r square now is what? Capital R, that's a radius, plus h, the distance for the satellite from the surface. Then after that, bracket, square. Okay, so now the R is stand for h plus R. So remember, we got three situations. One is a normal R, that one is in the Earth. Okay, number two is exactly surface. We're using capital R. Okay, for the satellite, normally it's a satellite lah. Satellite far away from the Earth, we need to using radius plus h. Okay, so this one is the differences when you're using the formula for the gravitational force. Okay, so we need to apply these three different locations for the formula. Okay, now we're going to see this one. The Earth and the Sun. And the last one, this one is the last one. Earth and also the Sun. The Sun is the biggest lah. So we mentioned object in the Earth is the first situation or the second situation. Okay, object in the Earth is the first situation. Okay, this one is the Earth. The object is here. Okay, then the center. When you pull, this one is the first situation. R square. The distance, how many? So me and you, object in the city, in the Earth. So we are R square, normal distance. So you just measure our distance is 30 kilometer. So 30 kilometer, you go to square lah. That one is the first situation. Okay, second situation is on the surface. Okay, when the object on the surface of the Earth with the center of the Earth, that one is a second situation. Third situation is a satellite far away from the Earth. That one is a third situation. Now we see fourth situation, the Earth and the Sun. Okay, you see the Earth keep rotating the Sun. So this one is, you need to find out the distance from the Earth and the Sun. So from here, we're still using the same formula, but you need to know the R is what? The R is the center of the Earth to the center of the Sun. This one that we provide, we do know how many. Okay, there's a 1.5 times 10 power of 11. Okay, so this one, we take this one, you go to square. When you want to find this one, the gravitational force between the Sun and the Earth. Then the 2m, one is a mass of the Sun, another one is a mass of the Earth. Okay, depend the two body is what? Object body 1 and the object body 2, the mass you multiply. Then divide by the center to center distance. Okay, then the distance depend the situation you are 1, 2, 3 or 4. Okay, then we go to apply. So this one is a 4 different situations. So we continue. Okay, this one's the fourth one. Okay, distance between the center. Remember, many students, they forget. They say, oh, surface and surface. No, must be center of the Earth to the center of the object. So this one, we call it distance.